Hello guys, welcome to all the students here. Today my lecture will be about the basis of thermodynamics. You have all these thermodynamics in your syllabus in this semester, and you have to go through the books also. And before you go to the books, you must have to know certain points, you must have to know the certain things, and you must know the basics of the thermodynamics. What does actually deal these thermodynamics? Thermodynamics basically deals with the big particles, macro particles. In physics, in the language of physics, we should say the macro particles. Whereas there are other chapter, that is statistical mechanics, that deals with the microparticles. Now, the thermodynamics, when you go for the considerations of macro particles, there are some changes you will see in the first law of thermodynamics. When you go for the first law of thermodynamics, when you go for the second law of thermodynamics, I would like to discuss all these. First of all, I shall quote one formula. W is equal to JH. All you know. Because W stands for work done, J is the joules equivalent of heat, and H is the amount of heat. So in the left hand side there is work done, in the right hand side there is heat, and one constant is there, that is J. So this W is equal to JH formula, again, it has been changed in a different manner in a thermodynamics picture. You see the first law of thermodynamics, you will see that the formula is dQ is equal to du, d with the internal energy, change in internal energy, plus dW. So here in that equations there are W is equal to JH, W is the work done, and in the right side there is heat. And here the heat is there, the work done is there, but one extra parameter is internal energy. And again, you see one change is there, a big change is there. What is the change? The change is that here it is written dQ, change in the heat, dW, change in work done, du, change in internal energy. Instead of Q is equal to U plus W, it has been written here in that way. Why? Why is it written in that way? This is because of the fact that the internal energy in the periphery of thermodynamics cannot be measured absolutely. What do you know about the internal energy? The internal energy, suppose you would like to calculate the energy of some amount of gases contained in a container, suppose. Now, as we know from Avogadro's hypothesis, how many number of molecules are there? 6.02 in 10 to the power 23 at NTP. 6.02 in 10 to the power 23. 10 to the power 23. Suppose you want to calculate the potential energy of the molecules. So you first calculate this molecule first, then second this molecule, third this molecule. So there are 10 to the power 23 numbers. So how can you calculate? This is a big task, and that is not possible without having some statistical considerations and like this what we have seen in the statistical mechanics chapter, in statistical mechanics book. But here when you go for the thermodynamics, this is not within the periphery of thermodynamics, that it can calculate the internal energy in an absolute way. Sure. But we can calculate the change in internal energy. Keep it here, shift it here in different positions. You can calculate the change in internal energy. Simple. It's very simple to calculate this change in internal energy. So change in internal energy within the periphery of thermodynamics, within the considerations for the macro particles, you can calculate. So the formula has been deformed in a different way. dQ is equal to du plus dW, as we can calculate the change in energy, internal energy. And to meet these requirements, internal energy has to be written here as du, and as du we should write, we have to write, we'll put equations have been changed in a different way. dQ dq is equal to du plus dw. This is the basis of thermodynamics. This you must know before you go to the books. Otherwise, you cannot enjoy this. Because if you don't know why this kind of equation is coming here, this is dq, du, nothing. And even in the second law of thermodynamics, you see one thing. Entropy. There also, ds, you can see in the book, ds, the change in entropy has been written there. ds is equal to integration dq by t. So here also, the entropy is nothing but a measure of disorderness. Measure of disorderness in a single word. If disorderness increases, entropy will increase. Now this measure of disorderness, you cannot calculate in an absolute figure. You can calculate the change in entropy. So here also, in the second law of thermodynamics, the new parameters that will be entered, it will be entered in a way that ds is equal to dq by t. So students, all these things you must have to take into considerations. All these things you must have to take in mind to enjoy the actual basis of thermodynamics, to enjoy the thermodynamics in a whole, and to enjoy the reading of books, what you will achieve after some days, after some years, after something. I think everybody has understood, and for me, here this is the end of my lecture here. You just have it in mind, you just digest the things, what I have said, and then read the books. You can enjoy. Thank you. Thank you.